Hello and welcome to the AWS Innovate virtual conference. In this session, we'll be talking about moving your Microsoft .NET applications one container at a time. My name is Daniel Zoltak and I'm a solutions architect based out of Melbourne, Australia. Today, we are going to walk you through a journey of moving your workloads, both classic and greenfields, into AWS. So a brief agenda for today. We will cover off the history of the .NET Runtime and how it's evolved over the years. We will take a look at what Microsoft has been doing around emerging the .NET technologies into the AWS open source community and opening it up for everyone to use. We are also going to focus on how the developer experience has changed and how it actually has been re-engineered for doing work outside of the Windows development environment. We are going to demystify .NET on Docker and what containers actually are. Today's presentation is also going to be hands-on, where we perform a number of live demos. We will go outside of the slideware and show you how to work with Docker and deploy .NET applications using Docker on AWS. We will also walk you through what AWS has to support taking you and assisting you on your cloud journey. So let's talk about Microsoft.NET. .NET is a multi-language virtual machine, also known as the Common Language Runtime. It was released in the year 2000, and it had support for over 20 different languages, such as Pascal, Haskell, even COBOL, VB.NET, Java, and C#, where C# is the predominant language used today. All the programming languages could be compiled to run on a single unified framework. .NET was designed to abstract the Windows 32 API. And back in the day, developing against the Win32 API was a bit of a black art. For example, a lot of the return values from functions were undocumented, so there was a lot of trial and error when debugging to work out what was going on. Developers also had to deal with the Windows event loop as well. So if you ever had to build Windows applications on Windows, you would likely be building them in C or C++. You also had to learn about COM, which is the component object model, which is something else to learn to deliver high-quality applications on Windows. .NET was built to simplify, abstract, and make the developer experience on Windows much easier. .NET also allows developers to build applications rapidly for desktop, server, and mobile devices with a unified experience. And to support this experience, Visual Studio.NET was launched as the primary developer experience, which is a fully integrated development environment allowing developers to build applications rapidly on the Windows operating system. So what's been happening around .NET and the open source efforts? Well, Microsoft realized they had to standardize .NET to make it successful. So they approached the European Union Machine Association to standardize the .NET libraries and runtime. They released a shared source version known as Rhoda that was open source but closed to certain use cases. The runtime could only be used for academic or exploratory purposes, and it was successful but only in this small community. A few clever engineers had a closer look at Rhoda and thought they could do a better job. Rhoda was cross-platform at that point and could run BSD, Unix, and Windows. So the engineers thought, let's take all the learnings and move it to a Linux and even an OS X platform. So Mono was born, an open source project providing a set of platform compilers and runtimes. And today, Mono has evolved also to cater for developing applications on mobile devices. So Mono Touch was created that made it easy to build applications across devices on iOS and Android. Mono and Mono Touch have added support for Visual Studio, Xcode, and they've even created their own IDE, Mono Develop. The founders of Mono also created Xamarin, which is a brand for the commercial product lines, providing lifecycle management products for delivering applications cross-platform on desktop and mobile devices. And just recently, in early 2016 in fact, Microsoft has acquired Xamarin. So a great amount of open source ingestion is occurring into the Microsoft organization, which allows all developers to benefit. More recently, Microsoft decided to go full open source with the .NET Runtime and announced the .NET Core CLR, which is a streamlined, modularized version of the common language runtime, available across multiple platforms. It is an evolution of the .NET application component and assemblies. ASP.NET has also evolved and is now called ASP.NET Core 1, and previously it's been known as ASP.NET 5. Microsoft, just like AWS, has made a commitment to work closely with the Docker community to allow applications to be containerized and make them being more available to run across platforms. We will focus much more on that later. Microsoft has also created the Dotnet Foundation, which is a community that supports open source initiatives. So they've taken all the open source projects relating to .NET and the runtime environments and provided a platform for developers to influence, collaborate, and work together and take them to the next level. So, more on the cross-platform development experience. The premier developer experience on Windows is still Visual Studio. It was predominantly GUI-based, and more recently, it has become more command line centric. Now, developers have the option to edit cross-platform using third-party editors such as Emacs or Sublime, or Visual Studio Code, which is an open source Microsoft initiative. There are even extensions available for Visual Studio Code that provide similar functionality to Visual Studio, such as IntelliSense. To find out more about these extensions, visit omnisharp.net. Also, the command line experience is the same across platforms. So it doesn't matter if you are using Windows, OS X, or Linux. You can enable true automation end-to-end. So from a continuous integration and a continuous delivery perspective, building, compiling an application, and then testing and creating an artifact, such as a Docker image, and then delivering that artifact and deploying it on infrastructure, just like a number of folks have been doing in the open source community, is now possible. This is a big step for Microsoft. Here we can see Visual Studio Code running on OS X. Now we're going to take a look at the cross-platform development experience and build the ASP.NET Core sample application on OS X and then Windows. First, I would like to introduce you to Yeoman. Yeoman is a scaffolding tool for building out modern web applications. It's a Node.js application, so you need Node.js installed. And to get Yeoman up and running, you use the Node Package Manager npm and install the Yo package globally. And once you have Yeoman installed, you can install a number of different generators. So there are generators for building scaffolding for Angular, Backbone, React, Polymer, and many more. For ASP.NET Core, we have installed and using the ASP.NET generator. We'll now switch over to our terminal on OS X and run Yeoman. We run the Yo command, and that gives us a list of generators. We then select the ASP.NET generator, and then Yeoman presents a list of applications we can create. We can select an empty web app, a console app, various variations on web applications, even a class library project or a unit test project. For today's demo, we'll select the Web Application Basic project. We'll use the standard Bootstrap GUI for our application. We then have the choice to name our application. We'll go with the default, Web Application Basic. We can see here that Yeoman has generated out the scaffolding for our project and is also pulling in some Node.js project-related dependencies for building out the project. Bower, which is used for generating out JavaScript and CSS, and Gulp, which is used for automating various tasks for publishing out the project. Now, let's open up Visual Studio and take a closer look at what's happening and what's been generated out. So on the left-hand side here, we can see the File Explorer. We can see that Yeoman has generated out a home controller, various views, the WW root. Then we can see some configuration files such as the Docker file that allows us to build the application into a Docker image and run it as a Docker container. There is a project.json file that lists all the runtime dependencies to run the application. So if we jump back to the OS X terminal and change directories into the Web Application Basic folder, we can restore those dependencies and run the application. In order to do this, we need the .NET CLI tools installed, which I have downloaded from GitHub. Let's take a closer look at the .NET CLI. It provides functionality to create a new .NET project, restore the dependencies, build the .NET application, publish the project, run it, test it, and even pack it as a NuGet package. So what we're going to do now is restore the runtime dependencies that were listed in the project.json file. To do this, we type .NET restore. The .NET CLI is now reaching out to a NuGet repository on the internet and pulling in all the dependencies. I've run this demo previously, so all those dependencies have been locally cached in a global cache. So the .NET CLI was comparing to make sure all the latest dependencies were in sync and copied into the local project folder. Now that we have all the dependencies running, .NET Run will compile the application and run the application under the Kestrel web server, and it will be bound on port 5000. So let's select the URL and go over to our web browser, and then hit that URL. So shortly, we'll see the sample ASP.NET Core Web application up and running on OS X. So if we go back to the terminal, we can also see the Kestrel web server info logs being outputted into the terminal window. We can see that it has invoked the home controller and served out various static assets such as JavaScript and CSS. If we go back to the web browser, clicking around, we can see our application is running as expected. So now that we have the web application up and running on OS X, let's contrast that experience on Windows. So here, I have a Windows Server 2012 R2 instance running on Amazon EC2. I'm going to now open a PowerShell session. I already have Yeoman and ASP.NET and the ASP.NET generator installed. We'll select that and follow the same steps as we did under OS X. We'll select the Web Application Basic project, the Bootstrap GUI, and then name it Web Application Basic. Again, we can see the scaffolding has been generated and the ASP.NET generator is pulling in the Node.js dependencies, Bower and Gulp. Once that is finished, we can use the .NET CLI again to restore the application runtime dependencies and run the application. So we type .NET restore. The .NET CLI is reaching out to the NuGet repository and pulling in all those NuGet packages. Then .NET run to run the application. It's going to be compiled and run and bound to port 5000 on the local host. So let's select the URL and then open up our web browser and visit localhost on port 5000 on our Windows instance. In the background, we can also see the Kestrel web server outputting various info messages. You can also put it into a debug mode if you're debugging your application to get additional output. We can see the sample ASP.NET Core Web application is now up and running on Windows. Again, we can click around and see it's all up and running as expected. So as you can see, the latest .NET tools now provide a consistent developer experience across OS X, Windows, and even Linux. So what are the .NET framework and runtime options? So there's the classic .NET framework, which is Windows only and feature complete. There's the .NET Core CLI, which is Microsoft's new open source and cross-platform runtime. It's now feature complete and going through a stabilization phase and currently working towards release candidate 2. There are builds for Windows, OS X, and Linux. So head over to GitHub and check the code out behind the runtime. Then there's a Mono, a third-party cross-platform open source runtime. It has similar APIs to the classic .NET framework with a high level of compatibility. So how do we switch between .NET environments? With the command line tools, you can quickly swap between the various frameworks and runtimes. The .NET Version Manager, also known as DNVM, that comes part of the .NET CLI tools, can be used to download versions of the .NET execution environments and manage which versions you have. Be aware that the runtime support different assemblies and libraries on the various platforms. So here we can see the developer experience in Visual Studio running under Windows. IntelliSense is telling us that the StreamWriter class provided by the Westwind utilities is supported and available in .NET Framework 4.5, ASP.NET 5, however, is currently not yet supported in .NET Core. So developers have to be more aware of the kind of code they are writing, as some of the assemblies may not be available on the target runtime. So if you continue to focus on the Windows platform, you can continue to use the same applications and assemblies as you have in the past. If you intend to venture into the .NET or ASP.NET Core environments and planning on going cross-platform, pay attention to the warnings at development and compile time, either in Visual Studio or the command line. So how do you port your existing code to .NET Core? API Port is a .NET portability analyzer that is available to help you port your existing code to .NET Core. So here's a rough approach for porting. So in Visual Studio, identify the projects that you want to move to .NET Core and understand the external dependencies these projects have and ensure they are either compatible with .NET Core, have equivalent alternatives, or can be factored or out. And then change those packages to target .NET Framework 4.6.1. This ensures that you can use API alternatives that have been introduced for cases where .NET Core couldn't support existing APIs. And then make sure to also upgrade any consuming projects. Otherwise, you'll get compilation errors due to inconsistent .NET Framework versions. And then recompile and then run API port and then change your code to address API port issues. And then you repeat those steps. So recompiling and then running API port and then changing your code until all the API port issues have been addressed. Then create the new .NET Core project and move your code in. So what's the difference between runtimes and why should we care? So if we take a look at the classic runtime on the left-hand side, it's been built as a monolith. So if we take an application that is dependent on a few components in these assemblies, our application will require to bring in the whole assembly. For example, if our application required system.core.io, we would have to bring in the entire system.core assembly, which means that these applications would have a longer startup time and larger memory footprint. It also meant that Microsoft had to recompile the entire assembly whenever there was an addition or bug fix. The system.core contains additional frameworks such as system.core.io and system.core.file. And that meant longer lead times to releasing updates, as all the functionality encapsulated in those assemblies would need to be tested before a new version could be released. If we take a look at .NET Core on the right-hand side, it has been broken up into much smaller packages. So instead of building a large monolithic application, the assemblies have been broken down into smaller packages and packaged as NuGet packages. For example, system.core.io and system.core.file. So NuGet packages are packages that are self-contained application components that can be reused and rapidly imported into your application, as demonstrated in the previous demo. This means we only need to include the components our application requires, for example, system.core.io and system.core.file, which results in a reduced package size for our application and also means our application has a shorter startup time and smaller memory footprint. It also means any additions or bug fixes to an assembly can be quickly added, tested, and released, which significantly reduces lead times. So on to a very popular topic for everyone. Let's talk about Docker and containers. Microsoft, like AWS, have made a commitment to support the open source community some time ago to support Docker. So how is Docker different to virtual machines? So let's first look at the diagram on the left-hand side. We have our host operating system and a hypervisor, and on top of the hypervisor we have multiple virtual machines running side by side. The virtual machine images are made up of very large files containing the guest operating system, binaries and libraries, and anything else required to execute the application. The images are often tens of gigabytes in size and not lightweight, which makes them not easily shippable and more resource intensive to run, as the hypervisor needs to run the guest operating system, and that requires additional CPU and memory. If we contrast this with the diagram on the right-hand side, we have our operating system, the Docker engine, and the Docker containers running on top. The Docker images only consist of the runtime dependencies and the application itself, so much lighter weight, usually megabytes to 100 megabytes in size, which means they are easily shippable and highly portable across operating systems. They are also less resource intensive, as they have a smaller CPU and memory requirement. So a little bit more about containers. Containers simply contain all the application components and dependencies. And quite often, developers develop and compile an application on their local development machine, then ship it over to a server or pass it to someone else. Following this approach, the app may break the first time, as there may be potentially additional dependencies in the environment or operating system that may be required for the application to execute. By packaging and running the application in a container, the container will contain all the dependencies required at runtime. DLL hell traditionally has been a problem for developers, when multi-tenanted applications share core operating dependencies. Now you can get away from it, as a container is self-contained, where all the dependencies are isolated. So with confidence, you can ship the container around and have the choice of running it anywhere. So containers are not tied to any specific infrastructure. Containers can run on any computer, on any infrastructure, such as the AWS cloud. Containers also share the kernel of the underlying operating system and run as isolated lightweight processes in user space on the host operating system. The processes are isolated from each other, so you can run multiple Docker containers side by side, which will not interfere with each other, as the operating system and runtime environment will isolate the processes. And often, when you think about Docker, people think about Linux. Now, there is support for .NET. We can thank Microsoft for opening up and supporting the open source community to allow greater cross-platform execution of our applications. So why does it matter to .NET applications? For an existing application, we can take it and package it in a self-contained environment, aka a Docker container. Then we have the choice of running the application on Mono or .NET Core on different operating systems. We can also extend the life of our application beyond the platform they were on. So if we were running an operating system that's no longer supported from an update perspective, we can take our application, renovate it, containerize it, and run it on a supported operating system. And as a side effect, this may also save on licensing. So we can get more life out of our existing applications. For Greenfield applications, we have the choice of building them on .NET Core and have the choice of developing them in a slightly different way. We can develop them in Visual Studio or on the command line, or using Visual Studio Code across different platforms. We can develop them locally on our desktop or on AWS. There's nothing stopping you from moving your application into a modern DevOps world, where you can rapidly develop your code and ship it into production. You can automate everything from the moment you build the code to having it run in the cloud. And if you move the applications to AWS, you will gain the agility that AWS is so known for. Being able to rapidly provision infrastructure at a very low cost and scale to cope with very large loads. You get that with the AWS infrastructure. How does AWS support .NET and Docker? The first option you can look at is rolling your own. So running the Docker engine on an EC2 instance. This could be something you may have already tried to do on your local development PC. So you could develop the application and containerize it on your local development environment, and then ship it to an EC2 instance running in AWS. The second option is to use a rapid deployment service, such as AWS Elastic Beanstalk, which allows you to quickly develop and manage applications in the AWS cloud without worrying about the infrastructure that runs those applications. It also helps you to support the life cycle and ongoing operation of your applications. For example, different environments, so development, staging, and production. And it also facilitates deployment of the new versions of your application into those environments. Elastic Beanstalk supports running your .NET applications on Docker and running existing applications under iOS or Windows. You can also deploy your existing or Greenfield applications, and it's great for developers who want to quickly get their application up and running in the cloud. In addition to this, Elastic Beanstalk supports other languages such as Java, PHP, Ruby, and Go. For the final option today, there is using Docker as a service, such as the Ec2 Container Service. This is for advanced users using ECS to run Docker natively. ECS is a highly scalable container management service that makes it easy to run, stop, and manage containers on a cluster of EC2 instances. ECS gives you a great deal of access, allowing engineers and IT ops people to have full access to tinker with the underlying infrastructure. ECS has a lot of power to scale out or restart containers that have stopped or failed to launch or potentially crashed. So, in summary, each of these varies depending on your interest to tinker with the underlying infrastructure, such as with ECS, or just hit a button to deploy your application using Elastic Beanstalk. On to our final demo for this session. In this demo, we're going to create the ASP.NET Core sample web application in Visual Studio and run it on an EC2 instance running the Docker engine. Let's take a closer look at what's going to happen. We have our EC2 instance running Windows Server 2012 R2 with Visual Studio installed. We also have an EC2 instance running Ubuntu Linux and the Docker engine. In Visual Studio, we will then create a new project based off the ASP.NET Core sample web application, compile it, and then run it. To run the application, Visual Studio will connect to the Docker engine on the Ubuntu instance and create a Docker image and run it as a container. Let's jump over to our Windows Server 2012 R2 instance running on EC2. So we have Visual Studio 2015 Community Edition installed. I've downloaded and installed the Docker tools from Visual Studio from MSDN. Now let's open up a PowerShell session. I've also downloaded the Docker toolbox from docker.com, which contains the Docker binary. The Docker binary provides us the functionality to create, ship, and run our Docker images as a container on any host running the Docker engine. So let's connect to the Docker engine on the Ubuntu instance and check to see if any running containers are up by running the docker ps command. As we can see, there are no containers currently running. I can also use the docker command to list the Docker images on the Ubuntu instance. As you can see, the Microsoft.NET image listed has already been downloaded from Docker Hub, which is a repository for Docker images just like GitHub is for code. The Microsoft.NET image provides the .NET execution environment. This image will be used as the basis for building our new image to run sample ASP.NET Core web applications we create in Visual Studio. So if we go back to Visual Studio, we'll select a new project and select the .NET Core ASP.NET Core web application template. If we take a look at the Solution Explorer, we can see in the background Visual Studio is building out the scaffolding just like Yeoman was in the previous demo. We can see the WW root, controllers, views, and the configuration files. We also have the project.json file with a list of all the application runtime dependencies that are required to run the application, which Visual Studio has automatically downloaded in the background. With the Docker tools for Visual Studio installed, it gives us the option to add Docker support to the application. The Docker support creates property files, Docker files, and commandlets for creating a Docker image and deploying the application as a Docker container. The Docker tools for Visual Studio are still in preview, and assume by default we have the Docker engine running under a virtual machine on our local Windows machine. To build and run our container on the Ubuntu instance, we need to remove the Docker machine name from the Docker properties file and restart Visual Studio and reload the solution. Visual Studio will fall back to using the Docker host environment variable, which points to our Ubuntu instance. Now we can publish our application directly to the Ubuntu instance running the Docker engine. So we'll select the release build target and then press the run icon. In the background, Visual Studio will run the .NET CLI to compile the application, then publish the application to a local folder. Then it connects to the Docker engine running on the Ubuntu instance and creates a new image. So taking a look at the Docker file, it's using the Microsoft provided .NET image. Then it's overlaying the application on top of the .NET image and creating a new image. Once the new image has been created, Visual Studio will start the image as a container on the Ubuntu instance and then attempt to connect to the container. Once successful, Visual Studio will launch the web browser. So here we can see the sample ASP.NET Core web application has been successfully built and deployed as a container on the Ubuntu Linux instance. Now if we jump back to our PowerShell session, we can see the Web Application 2 image, which was created about 20 seconds ago. We can also see our container running, which has been running for about 20 seconds and is exposed on port 80. We can also see the Kestrel web server logs as we observed in the previous demo by using the container ID and running the docker logs command. As you can see, it's really easy to build a .NET application within minutes directly from Visual Studio and have it up and running as a container. In summary, Microsoft is making cross-platform development easier. The .NET Core Runtime has been open sourced. Existing .NET and Greenfield applications can run in Docker either under Mono or .NET Core runtime environments. You also have the option to speak to a friendly solutions architect like myself if you need help, so please reach out. To gain more confidence and hands-on experience with AWS, watch our instructional videos and explore the self-paced labs. Attend our instructor-led classes by qualified AWS instructors and learn how to design, deploy, and operate highly available, cost-effective, and secure applications on AWS. And then validate your technical expertise with AWS and use practice exams to help you prepare for AWS certification. Get more info at aws.amazon.com/training. Thank you for attending this session. We hope you found it interesting. Do provide us with your feedback and let us know how we can improve the event and experience for you in the future.